Good afternoon.
Good afternoon.
How is everyone today? Great, you?
Really great.
Well, to be truthful, I'm a little bit bummed.
Why not? Or why?
Because I don't want you to get the wrong idea, but so my Holbrook High School class, my calculus class in the morning, I was gonna surprise them, and there's a special showing of Avengers Endgame at the Roxy, and I was gonna take them on a field trip to watch that tomorrow. And would you believe the principal turned us down? Like vetoed the whole thing. So anyway, so I'm a little bummed out because I thought that was kind of a cool thing to do. So, but I am gonna get to see it. What?
You can take us instead.
Yeah.
What did you say?
You can take us instead.
Yeah. I'll go.
You ready? Yeah. No, I'll get to go on Saturday. Is anybody going tonight at midnight or whatever? Anyway, is anybody going tomorrow?
We are.
Saturday.
Yeah, me too.
All right. Well, that'll be good. Well, I know it's playing in Holbrook, so you can come see it then. But anyway, but I thought that would be a fun thing to do. So anyway, but I don't know if you guys remember, but I talked to him about one time having like a Talon party and having all you guys come together either at the beginning or the end of the semester. And that got vetoed too. So anyway, I hate it when parties get vetoed. That's no fun. So anyway, well, before we get started on the lesson though, I do want to talk to you a little bit about the extra credit for the evaluation. So this is on the Moodle. So right before chapter 6, okay, there's the course improvement survey. And remember I told you I was going to link it to extra credit. Turns out I can't do that because it's not a graded assignment. So this is what we'll do is notice right under that it says extra credit for survey. So you do the course improvement survey, you point and click, do whatever you need to do. Takes less than 5 minutes. Then you click on this, and it's a 1-question quiz that's worth 5 points of extra credit. It's true, false, and you have unlimited attempts. And the question is, did true or false, I completed the survey. If you click true, you get 5 points extra credit. Okay? So that's how we have to do the extra credit. All right, so once you do the survey, then you go right underneath it, and that'll take 20 seconds. Okay? All right, so any questions on that?
So are we still doing the essay thing too?
Yes.
Okay,
Now this is quiz points. The essay is 5 points on your final exam. So that's actually worth more.
so the paper you have where it shows what we need to do for that one, is it on here or something?
Yeah, so if you click, so under the section on the final, at the bottom, it says extra credit evaluation. Now you don't see the actual part 1, part 2, part 3 of the final yet, because it says hidden from students. So you won't see that. But this extra credit evaluation at the bottom, that has everything I went over the other day. Okay? The other thing that I uploaded was a practice final. So if you want some questions to practice on, now remember the not this Monday, but next Monday, I was hoping to have a day of review. So what I'll just field questions that day. I'm not going to prepare anything to teach. And so you ask me questions and then I'll go through it. Then what this is under here, I probably should put like smart board lesson or what. Anyway, this is the questions as people have asked me and from the practice final, and then I work them all out. And so if you ask me one, then I'll add to it. And then I'll upload the newer version of it after we do our class on Monday. Okay? Any questions on that?
Mr. Strong,
Yes, sir.
do you know if those videos ever started working again?
Yes, they did. So let's see. I've actually been uploading the last couple of days. Let's see. Where am I with your class? I think I'm up to the 22nd. Yeah, so anyway, no, I've got the 22nd. It's the 23rd. So I'm up to the 23rd. So that's pretty good. I mean, if you miss class Tuesday because of the ball game, that hasn't been posted, but I'm gonna try to get on that right after class to see if I can get those caught up. But yeah, I got them to work. There's some of them I do have to warn you where they were having trouble with the recording for about a week. And so there's like one day where your class didn't record. And so then I just put up the recording for the other class. And then there was another day when their class didn't record. And so, I just made it work. So but as far as the material goes, you're good. So, okay. So up till Tuesday, we should be set. All right. Anything else? Oh, so did anybody hit a home run on Tuesday?
Anna did.
I did.
Oh, did you
I
really?
hit 2. Yeah, I
What?
hit 2.
You hit 2 home runs?
Yeah.
Full 200.
Holy cow, that's pretty awesome. That's pretty awesome. Yeah, I think I heard let's see what was it? Yeah, I actually saw one of your home runs because I was standing next to the father of the pitcher and he was saying, "Dang, that Ballesteros girl." It was really funny. We were going back and forth because he had a son that was pitching for the boys and his daughter was pitching for the girls at the same time. So that was hilarious. So anyway, but awesome. All right. Well, anything else before we get started with our lesson today? Okay, let's see. Did I ask if anybody, or is anybody absent in Mogyan?
Maybe.
No.
How about in Alchstay?
Everyone's here.
And how about Hopi?
Dwayne and Ember again.
Dwayne and Amber. Okay. I knew I forgot something. All right. So today we're going to talk about our new section, 11.5, an introduction to combinatorics. Okay. And I'm also going to let's see. I'm gonna tell you a story today, and I'm also gonna tell you about my opinions on the lottery. We're gonna talk about the lottery today. So, anyway, we'll see how it goes. So this section is called an introduction to combinatorics. All right. So, what is combinatorics? In general, informally, you can think of it as the study of counting. Okay, if you're going to count stuff, all right, that's combinatorics. There's actually a class in college. If you're a math major, you take a college class called combinatorics, and usually after like calculus or whatever, it's like super easy to take. You know, hopefully, you'll find the next two sections pretty easy. So an example would be if we were counting the different types of telephone numbers. So telephone numbers in the U.S. have 10 digits, 0 through 9. The first 3 are the area code, and the next 7 are the local number. All right. So let's say within this within our area code. Okay, are y'all in 928? Is that your area code? Yes? Okay. So how many different phone numbers are possible within that one area code? Can anybody figure that out or tell me? Now, it does say that, there's another piece of information you need to know. And it says the local telephone number cannot begin with a 0 or a 1. Okay? So the 7-digit part can't start with a 0 or a 1. All right? So then how many phone numbers are possible within our 928 area code? So just shout it out if you have an answer or a guess. Anybody want to guess before I tell the answer?
I have a guess.
All right, what's your guess?
1,062,882.
Okay, now what's fascinating about that guess is I'm really curious as to how you came up with that. How did you get that answer?
Well, I just
Guessed.
yeah, totally. I just pulled out some numbers. No, so you can have like 2 possible numbers for the first one, and then
Okay, wait.
9.
Okay, wait. So there's 2 numbers you can't have. So there's 8 possible for the first one. Okay, keep talking.
And then there's 10 for the next 6 numbers.
Yes.
And so if I redo this and I do 8 times 10, 1 second. I got 8 million.
8 million is the answer. Good. Okay. So 8 million is the answer because within this one area code, see you've got 8 for the first one, and then 10 digits are possible for the other ones. So then you multiply 8 times 10 to the 6th, and you get 8 million. Okay? So there's 8 million numbers. Well, so for years, that was enough for the entire state of Arizona. And so Arizona would only have one area code. So what changed? Why do we need so many area codes now?
Because there's more people now. So there's over 8 million people in the state. So they need two different or several different area codes.
It's
So-
because there's
Well, see, actually, the population has grown a little bit, but not that much. Not that much.
it's because there's more phones.
There's more
Like
phones.
nowadays.
See, the number of people that use the phone. I mean, do you think when I was growing up that teenagers used phones? Sure. It's just we didn't have our own phone. We didn't have our own number. Okay. As a matter of fact, I lived in rural Mississippi when I was like 5 years old. And in Mississippi, they had, in the rural areas, they had what they called a party line. Have any of you ever heard of that? So a party line was like one phone line for a whole neighborhood. Okay? So when I was little, if ever I wanted, I mean, I guess I didn't make too many phone calls when I was 5, but you could pick up the phone off the receiver and you could hear your neighbor's conversation. Now, the polite thing was to hang right back up. But, you know, sometimes you like eavesdrop. It's kind of like if your sister's talking to her boyfriend in the other room, then you could go and pick up the other phone and hear her whole conversation. See, you guys have no idea what that's like, to really never know if you have privacy or not. Okay? It's a totally different thing. Anyway, all right, so but with the use of cell phones and so on, that they had to create more area codes. All right, but let me tell you a story before that happened. Is that so? When I was about your age, maybe a little bit older, that most states only had, unless it was like California or New York or something, most states just had one area code. And so I had lived a lot of my life in South Carolina and Utah. South Carolina's area code at that time was 803. And Utah's was 801. So one time I'm calling my sister who lived in South Carolina, and I call her up, and a young woman picks up the phone, and see, my sister would do this thing that if anybody was over visiting her neighbor or whatever, she would have them answer her phone, and it's really annoying, but that's what she did. So you never knew who was going to answer. So whatever. This is my sister Jody. Okay, so she answers. So some strange woman answers the phone, and I say, "Hello, is Jody there?" And she says, "No, Jody's not here right now. Could I take a message?" And I said, "Well," because I'm thinking this is her neighbor, right? So I said, "Could you tell her that her brother called?" And there was a little pause on the other line, and the woman on the other phone said, "This is Jody's sister. She doesn't have a brother." And I look at the phone, and it had the last number you could read that you dialed. And I realized I had called Jody's number, except instead of 803 South Carolina, I had dialed 801 Utah. And the very same number, only in Utah, was another woman named Jody that lived there. So what are the what are the odds, right? So anyway, so the lady says, I'm Jody's sister. She doesn't have a brother. And so then I said, "Well, I guess you don't know about Dad." No, I didn't say that. I wanted to say that, but I didn't really say that. Anyway, so I just hung up and laughed it off. But it was just so bizarre to me that very same number, there would be two Jodys across the country. So anyway, and nowadays, of course, you just program it in your phone. Nobody memorizes any numbers anymore. I bet half of you don't even know your own phone number. Maybe. I don't know. But anyway. All right, so let's see if you can apply what I've just been saying about phone numbers to a combination lock. It says a combination lock will open when the right choice of three numbers from 1 to 30 inclusive is selected. how many different lock combinations are possible. Now, what does this word inclusive mean? What does that mean? Inclusive. Well, it means that you include the 1 and the 30. Okay? See, the word between can be a little vague. Do you include the end points or not? So if we want to make sure that you include the 1 and the 30, you say inclusive. All right? So see if you can calculate it from there. All right, Denon, what do you think?
27,000.
27,000 is correct because there's 30 numbers that you can pick from the first. And then if you know anything about locker combinations, you can repeat the same number because you're going all the way back around. And so it'd be 30 times 30 times 30, 27,000. Now, what if you couldn't repeat? Then what would you multiply together?
30, 29, 28.
Yes. So if you couldn't repeat, then you would take 30 times 29 times 28, which would be 24,360. Okay. All right. Any questions on that? So this is what's called the fundamental counting principle. And it just says if an event can occur m number of ways, and then there's another event that occurs m sub 2 number of ways, then the ways that they can occur, the different number of ways they can occur would be m1 times m2. Or if you have 3 events, you multiply 3 or 4 or 5. So like if you go into your closet in the morning and you have 4 shirts and you have 3 pairs of slacks and you want to know how many different ways that you can assemble your wardrobe that day, you just do 4 times 3. So there's 12 different ways that you could go. Okay. All right. So let's say I go to Subway. Subway has a special. And the special is, let's say, of the 6 kinds of bread, you can choose 1. And you can choose 1 of 7 kinds of meat, 5 kinds of cheese, 10 kinds of sauce, 9 kinds of vegetables. Then calculate for me how many different kinds of sandwiches you could make. All right, Hannah W.
18,900.
18,900. Okay? So you just multiply those numbers together. All right? So, they say that's why people don't get tired of Subway like they do, say, McDonald's or something, because there's so many different combinations that you can do. Okay? All right. All right, so see if you can do this one now. All right, Hannah, it's your lucky day.
Oh, I got 6,760,000.
There it is. 6,760,000. So now the number of automobiles would exceed that in most states right away. Okay. Doesn't take long to get that many automobiles, even like in Arizona. So then what they do is they'll just add a digit. Or maybe instead of starting with 2 letters, they'll start with 3. Or, maybe they'll put the numbers first and then the letters last. So there's all these different ways when they come out with a new edition of license plates, they'll mix it up so that they get sort of a new set of numbers that they can a whole nother 6 million or 10 million or more, 60 million. I know when I was in California. So I'd never been to California before. I'd served my mission. I go to California and their license plates are 8 digits long. I'd never seen so many digits on a license plate before. Okay, but it makes sense. There's so many people. Well, then I had this companion from Wyoming, and we see this truck with a Wyoming plate, and it had 3 digits. I'm not lying. 3 digits. And I told him, I was laughing. I'm like, does this mean there's more sheep in Wyoming than people? And I mean, 3 digits. But then, does anybody know anything about Wyoming's license plates, how they're different than any other state's plates?
They're from Wyoming.
Well, that's true. But there's something unique about Wyoming's plates in that there's like a little number kind of to the side, and that's actually the county number. And I didn't know that until this buddy of mine, he's like, oh, they're from Cheyenne or something like that. And I'm like, what? How do you know that? Just looking at the plate. And he's like, oh, because they're county 17. And I'm like, well, so what are you? And he's like, 1/2. No, he said, yeah, I can't remember the other one. 1/2. And anyway, so instead of 12, it's 1/2. And so that was from Star Valley. It was 1/2. Now I know that for the rest of my life. But so then once in the county, they would only need like 1,000 plates. Anyway, crazy stuff. All right. All right. Now, one important application of the fundamental counting principle is determining the number of ways that n elements can be arranged in order. So an ordering of n elements is called a permutation. So a permutation is when the order matters. All right, so in general, when you're calculating a permutation, the number of permutations of n elements is n times n minus 1 times, you keep going until you get to 4 times 3 times 2 times 1. Well, that's the definition of n factorial. So the little exclamation point after a number, you read that factorial. So like 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? Now, you can actually do the factorial on the calculator. Maybe I can show you how to do that. Maybe not. Let's see. Okay. All right. So these are the keys that you hit to get to the factorial. Is you, let's see, let's just go to it. Oh my gosh. So the touch screen has quit working on us. Okay. Okay, so to get to the factorial, let's say you want 7 factorial. So you do 7, and then to get the factorial, the little exclamation point, you go to math, and then arrow over to PROB, which stands for probability. And so then the fourth option is the factorial. So 7 factorial, you press enter, and that's 5,040. All right. So if you want to know how many permutations are possible for the letters A, B, C, D, E, and F, you just say, well, okay, there's 6 letters, so it's going to be 6 factorial. Okay, or you could think about it, you could kind of reason it through and say, okay, so in the first position, you could pick any one of the 6. In the second position, see, there's 5 left, and then 4, and then 3, and then 2, and then 1. And so then you could use the fundamental counting principle and multiply. But again, that's the same thing as 6 factorial, so 720 would be the answer. All right, any questions on that? All right, so do this practice problem, please. All right, so Rachel?
40,320.
There we go. Any questions? Okay. So if n is a positive integer, the notation n factorial means n times n minus 1 times n minus 2, all the way down to 3 times 2 times 1. That's sort of the definition of the factorial. Also, 0 factorial, by definition, is 1. Now, I know it seems like it should be 0, but it's not. It's 1, by definition. Okay, now, let's say that we're not using all of the elements. So if we're going to arrange 7 books on a shelf, then there's 7 factorial ways to do it. But suppose that of those 7 books, we only want to take 2 of them. Then that would be a permutation of 7 things taken 2 at a time. So that would be NPR, and this is the formula for it. It's n factorial over n minus r factorial. So let's say I had the permutation of, so let's say I have 7 books, and I want to know how many ways can I arrange 2 of them on the shelf. So that's 7p2. So that would be 7 factorial over 7 minus 2 is 5 factorial. And then when you simplify that, this is how you simplify factorials. You say, well, 7 factorial is 7 times 6 times 5 factorial. And then you just stop there because this 5 factorial will cancel with that 5 factorial. And so then all you're left with is 7 times 6, which is 42. Now, your calculator can also do a permutation of just so many things taken at a time. So if I wanted to do 7p2 in the calculator, I would go to math again and probability. So the same menu. And if you look, the second option is NPR. So if you press that, so then I put a 7, meaning I have 7 things. Then I put a 2, meaning I'm picking 2 of them. And I want to know the permutation of 7 things, or I pick 2 of them, and the answer is 42. So it's the same, you get the same answer. All right, any questions on that?
So, Mr. Strong, when I do the NPR on my calculator, it doesn't let me plug things in. So it just says NPR.
You put 5 there and 2 on that side.
Yeah, so you have an older calculator. So then you would put the number first, then the NPR, and then the last number. Well, actually, let me go do this example here first. It says 8 horses are running in a race. How many different ways can these horses come in first, second, and third? Assume there are no ties. So the order matters because coming in first is different than coming in third or coming in last. So the order matters. So this is a permutation. So then you say, okay, I have 8 horses. I want to know how many ways can I arrange them to come in first, second, third. So that would be 8p3 if you put it in your calculator. If you wanted to reason it out, you could just say, well, there's 8 choices for first, then 7 for second, 6 for third, and then you can just multiply those together. Or to put them in your calculator, it would be the 8p3. So then you could do it by hand or put it in your calculator. All right, now in the example problem that you've started on, it says a coin club has 5 members. And how many ways can a president and a vice president be selected from its members? Well, there the order matters because president is different than vice president. So the order does matter, so it's a permutation. All right? All right, Shalisha, what do you have?
Is it 20?
It is 20. Okay. So you can kind of reason it out. You can use the formula, or you can put it in your calculator. However you want to do it, the answer is going to be 20. All right, any questions on that? Okay, so next we have what we call distinguishable permutations. Because, see, like, let's say if I had the letters A, and I rearranged them. Well, you couldn't tell. Okay, so, because they're indistinguishable. So if you have objects that repeat, then it alters the formula. Instead of just n factorial, it's n factorial over n sub 1 factorial, n sub 2 factorial, n sub 3 factorial, where these are the numbers of the repetitions. So you have the total objects on the numerator, and then the number of repetitions factorial in the denominator. Okay? So let me give you an example. All right. In how many distinguishable ways can the letters in banana be written? See, if you just switch the two ends or something, see, you couldn't tell. So what you do is you count up the total number of letters. So that's 6. So 6 factorial goes on top. Then you say, all right, I have 3 A's. So that's 3 factorial. 2 N's, 2 factorial, and 1 B, 1 factorial. You don't have to do the 1 factorial if you don't want. But so then to simplify this, you go, okay, 6 factorial is 6 times 5 times 4 times 3 factorial, and then just stop there because that'll cancel with this 3 factorial. And then the 2 will cancel with the 4, so you end up with 60. So it's the total letters over the repeats. And see, that's a lot easier than writing them all down and then counting them up. I mean, that could take you a long time. Okay, so let's see if you can do this one. All right, so hand me when you've got it.
Is it 1,500, 120?
All right, let's see. 15,120. Is that right? So you say, okay, you have 9 total letters up here, so 9 factorial over 2 A's, so 2 factorial, 3 E's, 3 factorial, 1 J, 1 factorial, 2 P's, 2 factorial, 1 J. And again, the ones you don't have to put in there. All right? All right, next, we want to talk about the combinations. It says when you count the possible permutations of a set of elements, order is important. But if order is not important, then it's a combination. So,
Mr. Stone,
yeah?
real quickly, could you go back to the other slide just real quick?
Sure.
Okay, that's all.
Thank you.
So, like here, ABC and BAC, these would be different permutations, but they would be the same combination. Because in a combination, the order isn't important. So, if I wanted to know how many different ways can I choose 3 letters from A, B, C, D, and E, then see I have ABC, ABD, ABE, ACE. Anyway, I could go through and list them. There's 10 of them. Or I could put in my calculator 5C3. So that means the combination of 5 things, choosing 3 at a time. Now that's pretty much in the same menu, is the other one. So you go to math, probability again, and then see you have in CR. So you hit that, and then so 5, C, 3, and so that's going to be 10. Okay. All right, so see if you can do that one. All right, so Jordan, when you've got it.
Is it 21?
Yep, there we go. All right, so again, so if the order is not important, it's a combination. Okay. So there is also a formula for a combination. So you can do it in the calculator or use this formula. So the combination of n things chosen r at a time would be n factorial over n minus r factorial times r factorial. Now, there's also another way that we can write combinations with this like n over r in parentheses. And we're going to need to know this on Monday when we do what's called binomial expansion. All right, so let's just talk about the lottery for a minute. All right, so if we have the lottery, all right, so with the lottery, you actually choose, okay, so you have the numbers 1 through 59, and you choose 5 of those numbers, okay? Then you choose, we're going to play Powerball because then we can get really rich, right? So then you have like a red ball, you choose, out of 1 through 39, you choose one of those, all right? So can anyone tell me, is the lottery a permutation or a combination?
A combination?
It's a combination because the order that you choose the numbers doesn't matter. Okay? As a matter of fact, when they're arranging the little ping pong balls, they actually reorder them from least to greatest when they're announcing what the winning numbers are. So the order doesn't matter, so it's a combination. Okay? All right, so how many ways could I choose 5 numbers between 1 and 59? How would I calculate that? Some of you are putting stuff in your calculator. What is it that you're putting in the calculator?
So you do 59 because 1 to 59 is the chances you have. Then you do C because it's a combination, and 5 because you can choose 5 numbers out of 59.
That's right. And so then for the second part, 1 through 39, choose 1. Then what would you do? There you would do 39, C1. Okay? Then, using the fundamental principle of counting, for both of those things to get to match, you would multiply these two values. Okay? So now I want you to actually put it in your calculator and tell me what you get. This is the total number of possibilities. All right, I guess. All right, so Rhett, when you've got it.
195,249,054.
There it is. That is absolutely true. So you've got over 195 million possible combinations here. Okay? And so you think that when the jackpot is $10 million, that's worth playing? No, your odds are so low, that this is kind of how I say if you're gonna play the lottery, okay, then this is kind of how let's say that there's about 20 people in this class, okay. So let's say we wanted to do a class lottery, all right? So let's say everybody brought in $1, all right? So you brought in $1 and you give it to me. You send it to me, all right? Then I'll go to the random wheel, and whichever one it picks, they win the lottery. So I'm going to give them how much? I'm going to give them $10. Now you might say, well, wait a minute, I thought we had $20. Well, I'm the state, and the state takes half off the top. So I'm going to give the winner $10. Oh, but wait, that just moved you up in a higher tax bracket. So of that $10, you have to pay tax on that. And so we're going to say $5 of that is going to be tax. So we're going to play the lottery. The winner gets $5. The state gets $15. So who's the real winner here? The state. And all you suckers that put in $1 thinking you were going to get $20, your math is way off. And so that's why I say that the lottery is a special tax on people who don't understand math. Okay? That we're going to make them pay extra because they didn't pay attention in their math class. And so they're going to pay an extra tax for the rest of their lives. Okay? So, anyway, that's just my opinion. So, anyway, that's it. We'll pick it up from there on Monday. You guys have a great weekend. If you haven't seen Avengers, I'll tell you how it ends on Monday. Okay, don't worry about that. I'll tell you who dies and who lives. I'll fill you in. You can save your money. I'll fill you in on Monday. So, okay. All right. Well, have a great weekend.